Welcome to Fun with Science, Engineering, and Technology. My name is Mr. Ross, and my assistants this morning are Brian and Angel. All right, what we're going to do this morning is a very interesting experiment. We're going to do a little bit with some osmosis. All right, Ryan, can you read what osmosis is?
Osmosis is the movement of water across semi-permeable membrane from areas where the water particles are more concentrated to areas where they are less concentrated.
Okay, so there are a lot of words in there, right? Do we know what they all mean?
No.
We don't know what they all mean. Let's start out with that first one, the one that's hard to pronounce, semi-permeable. All right, that comes from a word called permutate, all right? And what it means is to pass through. All right, so permeable is something that allows something to pass through it, all right? Semi means part of the thing, right? Doesn't let everything pass through. So semi-permeable, what it means is some material will let some things pass through it and block others, right? And basically it's all based on the size of the particles. Mm-hmm. One good example of what might be a semi-permeable membrane is, what's this?
Tea.
This.
A coffee thingy.
It's a coffee filter, right?
Yeah.
What's in there?
Coffee. Coffee.
How do you know it's coffee?
Because you can smell it.
You can smell it?
Yeah.
How can you smell it? There's no little coffee beans coming up your nose. Can you smell it?
It's like the scent.
The scent?
Yeah.
Can you smell it when it's way over here?
No. It's up close.
When it gets up closer, 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 closer. So the aroma, the vapors off of those coffee beans are diffusing, right, or they're permeating through the air into your little sensors in your nose, and you say, aha, I look at it, it's brown, I can smell it, it
smells good.
Smells good, it smells like coffee. All right, so I have this coffee filter. Now a jug of water.
I'm thirsty.
All right, so hold the coffee filter up a little bit. Just pick it up out of there. Pick it up, 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 where everybody can see it. I'm going to pour some water in there. What's happening?
The water's turning yellow.
The water's turning a little bit yellow because it's dissolving some of the coffee out of the coffee beans. But what about the coffee grounds?
They all got wet.
They all got wet. Are there any down here in this container?
No.
No?
No.
They couldn't pass through that filter, right?
Nope.
The water would pass through, right? That colored water and everything passed through the filter.
Mm-hmm.
But the coffee grains couldn't get through it because they're too big. So that is a good example of a semi-permeable membrane. The membrane being a little thin material, right, like that filter, right? Do you have a semi-permeable membrane? Of
yeah.
your very own? What?
Sweat.
You have one? He has sort of the right idea. He's saying sweat or perspiration, right? Where does it come from? When you're out and you're jogging along in the summertime, like I know you all do, getting your exercise. All right, it comes through your skin, right? You get little water droplets come through the skin. Is it anything else coming through the skin?
Blood.
When you go out and you exercise, you get blood out of the skin, all right? You're in bad shape. No, so your skin, all right, a lot of the animal tissues are semi-permeable membranes, like the skin, your intestines. There's a membrane around your brain. It's a semi-permeable membrane. Your body's made up of what? Little cells, right?
Yeah.
Each one of those little cells has a membrane around it, and it's a semi-permeable membrane. It allows nutrients to get into the cell, and it allows waste material to get back out. Right? So these things are semi-permeable membranes, not only just my coffee filter, but there are a lot of them around. Right? Now then, there's another word on there, which I know you don't do, which is concentrate. What's that mean?
They concentrate to one area.
Concentrate on one area, right? In other words, you're concentrating on me right now, right? Are you?
Not really.
You sure?
Yeah.
Okay. Well, that's one definition of concentrate. But the other one is the amount of things in one spot, right? If we take this room that we have here now and with just the three of us that are in the room, right, we have a certain concentration of people. If we put 4, 5, 6, 20, 30 people in the room, what happens to the concentration?
Gets bigger.
It gets more, right? If it's the three of us in the room, right, and we fill the rest up with dogs and cats, what happens to the concentration of people?
Still 3.
It's still 3, so it stays the same, right? So this room, if we fill it with dogs and cats and there's only the 3 of us in here, the concentration of people is still 3. It's still the same. Okay? So it's less concentrated with people. So what I'm going to do is, that's water. But before we start, though, let's spread this newspaper out. You were wondering what the newspaper is for?
I was reading it.
Okay. Well, I didn't put it out there for you to read it. I put it out there so when we make a mess,
Good clean
it's
up.
easier to clean up. Okay? That's water. That's OJ, orange juice.
Oh, I thought that was yolk.
No, that's not the egg yolk. This is salt water. Right? You look at it, there's some salt down at the bottom, all right? Salt water, orange juice, dishwashing detergent. I know you guys don't wash any dishes, right?
Yeah, because it's all gooey.
It's all gooey.
And vinegar.
And, no, that's not vinegar.
Is it?
It's ginger ale,
Oh.
right?
It's like
And,
ginger ale.
yeah, put that there.
Corn syrup.
And we have some Karo syrup.
Oh, that's what I was saying. I thought it was vinegar.
Now then, tell me which one has the largest concentration of water.
The water.
Where's the water?
Right there.
Right
First one.
Okay, what about the water and the salt water? Which has the greatest concentration?
Still water.
Still water. The water and the orange juice, which has the greatest concentration of water?
Water.
Water, right, because it's all water, right?
Water.
This is all water, so it's like we feel like filling this room up with people, right? We have a real high concentration of people in the room. And this one has got water in it, and it's got some other stuff
Juice.
from the juice, right, that makes it. So if we take these 2 containers, they're of equal size, we've got equal amounts in each one of them, right? There's less water in this one than there is in this one, right? So less concentration of water here than there is over here. And the same is true for all the rest of them. Okay, so are you sure that's the same idea with the salt water, which has the highest concentration of water?
The water. Because the water has salt.
Because this one has salt in it, right? And there's little salt molecules or salt particles are taking up part of the space in here. Like if we filled the room with dogs and cats would be taking up some of the space. Okay, so let's take those and why don't we just set them over there? Angel, you're in charge of all of my water concentration stuff. Now, so if we want to do an osmosis experiment, what we need is some water, right, at different concentrations, and we also need this semi-permeable membrane. Where am I going to get one of those from?
An egg.
An egg? You don't want me to take some skin off your arm and use that, right?
No.
Or part of your intestine or anything. You want me to use an egg,
Yeah.
which is what this is, right?
Yeah.
This happens to be instead of a fresh egg, I guess a hard-boiled egg, right? Normally it would have a shell around it, right?
Mm-hmm.
A little hard shell. And that hard shell is made out of calcium carbonate for the most part. It has a few other things in it, right? And underneath it, when you crack an egg open, crack that shell open, what do you find?
Yolk.
Okay, there's a yolk in it, but right inside the shell, what is there?
The white stuff. The clear stuff.
The clear stuff, okay? The clear stuff, which is when we hard boil it, turns white like this. Now, Mr. P said that's got to be a model egg because it stands up like that, because it has this little flat spot on the inside of it here. See a little flat spot?
Yeah. Because it has space in it.
Why?
Because when it does, the egg, it always has like a little bit of space on top.
Why?
Mm.
You don't know?
No.
Okay, I'll tell you why. This normally has a hard shell around it, a calcium carbonate shell, which is egg-shaped, right, because it fits around the egg. And it has little holes in it. It has about 17, 18,000 little holes. That's your homework for tonight. Go home, get an egg out of the refrigerator, and count all them little holes.
I can't see them.
Well, get a magnifying glass and look at them, all right? Make sure he does that. Now, when the egg is laid by the hen, all right, it's warm. After she lays the egg, then it starts to cool off a little bit. Right? And things, when they get colder, do what?
Dies off or something?
They contract, they get smaller. Right? So, as the egg cools off, the inside of it gets smaller. The outside, the shell, stays the same, but it's got some little holes in it. So what allows to happen is it allows some air to come in on the big end of the egg, which is where most of the holes are, and there's a little air space up there. And that's why when you hard boil it, you get that little flat space like that. Now, let's take a look at this egg. All right, there are all kinds of scientific names for the parts of the egg, but we're not going to worry too much about those. There's the egg. Right? This white part out here is the shell, which is that calcium carbonate. Right? And here's what we call that thing?
The yolk.
The yolk. All right, and this part here is the egg white. All right, what we normally refer to as the egg white. It's the clear part. When you crack the egg open, it's all clear. And you see these little curlicue things we have here? Believe it or not, those are little stringy egg whites. Right? You don't normally see them. And what their purpose is to hold yolk sort of centered in the egg so that it doesn't bounce around.
Like a cell or something.
Yeah, it's like a little cell. So now then, when you crack that egg open, and if you look at it real careful, when you take the shell and crack it, you look on the inside, that shell, right there, up at the space, you can find it up there where that hole is, right, where the flat part is. There's a little thin membrane, which I have outlined here in blue. Okay? It's a little membrane around that egg. And then there's a semi-permeable membrane. So, I've got a source for, like you said, from the egg. I have a source for my semi-permeable membrane. Okay? But I need to get that shell off. How do I do that?
Crack it.
Like,
Well, I can sit there and this little piece of sandpaper and very carefully take it off. Right? But there's an easier way. How did you do it up in the classroom?
we put it in vinegar.
You put it in vinegar.
I mean,
And- yeah,
vinegar.
that's what you
vinegar,
did.
Yeah, vinegar.
Smell it. Vinegar, right? Just like your salad. Right?
Smells bad.
There's an egg, right? And there's another egg. Pick them up. Don't squeeze it too hard, but that's why I put the paper down here, because I figured if we squeeze. And if you look at it, hold it up, you look at it, you can see the yolk on the inside, right?
Yeah.
Okay. And what we did, how we got it this way, is we put it down in some vinegar, left it for a day or so, and that vinegar is an acid which dissolves that calcium carbonate shell, and then you can just wipe it off. Right? It doesn't all come off at once.
Oh yeah, that's why. Like when you boil the egg, it always has that like stringy piece outside.
Yeah, that's like a little stringy. That's this thing right here.
Yeah, the stringy
Alright.
piece.
Right? Then that is a semi-permeable membrane. Now, what can you tell me about this egg? You're holding it.
Yeah, it's squishy.
It's squishy. What else?
Feels like a
And-
ball.
Hmm?
Feels like a ball. Like you can bounce it or something.
It'll bounce a little bit, right?
It stinks.
It smells because of the vinegar,
Yeah.
right? What else about it?
And you can see like all the yolk inside.
You can see the yolk inside. Anything else? Angel, what do you think? Huh?
No, the yolk is hard though. You can tell the yolk is hard inside.
You can tell the yolk is in there floating around because there's a little
Yeah.
membrane in there that holds it together. What we've done is we've lost these little stringy pieces because I'll explain why in a minute. That's why it's floating up and down.
Right.
Anything else about this egg? Well, you guys are going to grow up to be scientists. You gotta be observant. There's one other thing about this egg that you need to observe.
See through it.
You know, you can sort of see through it. It's sort of translucent.
And
How does it feel besides squishy?
like soft, very soft.
It's soft, it's squishy. What else?
Oh,
It just
Fragile.
feels very.
Okay, it feels fragile, but what else? All right, let me ask, Ryan. No, I want your hand. Give me your
Oh, my
hand.
hand?
Yeah. Now, does my hand feel like that egg?
No.
Why? What's the difference between my hand and that egg?
It got that outer layer thing.
Hold on. I'm trying. Does it feel warm?
No, it's cold.
It's cold, right? Why is this egg cold?
Because air is going through it.
Because air is going through it? That's
Because it
sort of.
doesn't got that shell anymore.
Let me ask you a question. You go out in the summertime and you jump in the swimming pool
Uh-huh.
and you come out.
You get cold
You feel cold. Why?
because you're wet.
Because you're wet, right? And why, just because you're wet, do you feel cold?
No, because the wind,
The wind is doing what to the water?
getting it cold and stuff.
That's what's causing it to be cold is because the water is evaporating, right? And when the water evaporates, it cools you down. The same thing is happening right now to this poor little egg, right? Because inside that egg, there's some water, right? Out here in the air, there's also some water vapor, but where's the highest concentration of water right at the moment? In the air or in the egg?
In the egg.
It's in the egg, right? So what's my osmosis thing say? What's supposed to happen?
The movement of water across the semi-permeable membrane from areas where the water particles are more concentrated to areas where they are less concentrated.
Right. So I've got a high concentration of water in the egg compared to what's out here in the air. So what's happening? I have a semi-permeable membrane. There's a little bit of water coming out through that membrane. It gets out here on the outside surface, and what happens to it?
Evaporates.
It evaporates. So what's going to happen to the egg?
It's going
It's
to
gonna
dry
get
out.
cool. It's going to cool down a little bit. Just like whenever you come out of the pool. Okay, now, that's a question. Are these two things the same size?
No,
No.
that's bigger.
This one's bigger. They were the same size eggs when we started. All right? This one's bigger. And the reason this one is bigger is because we've had it sitting in some vinegar, and vinegar has a little bit of water in it. In fact, vinegar has a higher concentration of water than the egg. So the water, while the vinegar was dissolving the shell, the water from the vinegar was going into the egg. When the shell got off to where there was nothing holding it down, this egg blew up like a little balloon, right? So it got bigger. But it started out, believe it or not,
That's small.
same size as this other one, right? Okay. Now, let's do something to this poor egg,
Poor egg.
right? Give me the K-Row syrup. Now, you know what K-Row syrup is?
Syrup.
Corn
Yeah.
syrup.
It's corn syrup, right? How do they get corn syrup?
Through the corn.
Through the corn.
They squeeze the corn thing.
They squeeze the corn out. Okay. Why is it sweet?
Because they added, ingredients.
They added ingredients. Well, this one happens to have some vanilla in it, but normally, no, they don't add any ingredients.
Probably it's natural.
You remember photosynthesis?
Remember that word, but I don't know what it means.
Yeah,
Oh.
it had something to do with plants, right?
Yeah.
Green plants.
It goes to, the plant goes to the sun.
Okay, it gets the sunlight,
Yeah.
right? And what it does is the plant takes in carbon dioxide, water, sunlight, through this process called photosynthesis, it generates oxygen, and what else? Sugar,
Sure.
sweet stuff,
Oh, like sugar cane.
food, right? In fact, you can't make food.
No,
You
you
can't go home and make a chicken, right? You can prepare one, you can cook it, fry it, and do all those things you wanted to do to it. But plants make food. They're the only thing that can make food. Right? You can't do it. Right? So all our food the plants all die off, you know, we lose all of our source of food. And we're going too. So what they do is they take the corn stalks and they squeeze them, squeeze all the juice out of them. And the juice has got what in it?
Syrup.
It's got some sugar, right? So then they put it in a big pot and they boil it, boil off all the water and keep the sweet stuff. So most of the water is going out of this. So this has a very low concentration of water in this Karo syrup. So what I'm going to do is I'm going to take, this is our cooking show, right? I'm going to take, and I'm going to, watch how that pours out of there now. Is it running out real fast? It's sort of gooey and sticky, right?
Mm-hmm.
Okay. And I'm going to dunk my poor egg. Don't anybody claim I'm abusing the egg, right? In some Karo syrup. What's going to happen? Which has the greatest concentration of water right now?
The egg.
The egg, right? So what's going to happen to the water?
It's gonna come out.
It's going to come out through that semi-permeable membrane because of this thing called osmosis and into the syrup. So when we take the water, Angel, you want to take that back? When we take the water and we start taking water out of this egg, what should happen to it?
It'll dry up.
It'll dry up. Well, at least it'll obviously get a little bit smaller. Okay.
Yeah.
That's going to take a while for that to happen. But down in here,
You already got one of those.
I already got one, just like Julia Child. Okay.
Yeah.
We got one underneath the sink or in the oven that's already been in there for a while.
Yeah.
Okay.
That's nice.
So we're going to have to do a couple things here with it. Get another container, get a little water. All right. You know what this water's for?
To put the egg in.
Well, no. What that water is really for right at the moment is for me to wash the egg off and wash off my fingers, right?
I'll do it.
Because I'm going to get all kinds of goop, right?
Ew. That's gross.
What do you mean it's gross? Here,
Oh,
so hold that up so
soggy.
everybody can see it.
I'm afraid to break it. It feels like a rock.
Looks all soggy.
What? Look at it.
It's all dried up. Like
It's
a
all
prune.
dried out.
It's like a prune.
It's like a prune. Yeah. But there you can see the little yolk. And why is it all lumpy like that? I mean,
Because you took out the water.
because the water came out of it into the Karo syrup, right? And which is what do we call that? Osmosis.
Osmosis, yeah.
Which is the movement of water from an area of high concentration through a semi-permeable membrane to an area where there is a lower concentration of water. So what I'm going to do is I'm going to put it in here, and if we left it there long enough, it'll eventually get back looking like those things over there. But I want to,
Probably a little bigger.
well, we could make it get a little bigger if we leave it in there long enough. But what we're going to do right now, before we spill things all over the place, what happened to my button? Okay, you hold that. Now I want you to watch when I pour this Karo syrup into the bottle. Watch it. What can you say about that?
It's going in
Did
smoothly.
it look like when I poured it over in here?
No.
No, it's runnier, right?
Yeah.
Why is it runnier?
Because the water.
Because the water from the eggs in the Karo syrup. Okay. All right, so now then, that's one less thing we have to spill. Let's put it over here. Okay. One more thing that we can talk about. I have here an egg, has a hard shell on it, okay? And what I did is I cut a little hole in the top of it, took a little sharp thing, pecked a hole in it, and put a straw in it. Isn't that nice? Did you do this in the glass? No, you didn't do this one. Okay. I didn't figure you did. All right. And I put some glue around here so that I could seal it up nice and tight so nothing could leak out the top. But look at the bottom of it.
You can see through it.
What about, there's no shell down there, right?
No.
How did I do that?
You probably just put like the tip of it.
I put just like the tip of it down in some vinegar, right? And dissolved that calcium carbonate shell down there. And so I have a little bottom part there that's my semi-permeable membrane that's exposed, right? And the shell's holding the rest of it together. So now then, if I take that and I were to set it up here in some water, what do you think's going to happen? I put a little water in.
I don't know.
You don't have any idea?
No. They'll probably do the same thing as that one.
So we put some water in there like this. All right.
Let me turn back white.
What do you think will eventually happen?
It'll probably fill
Where is the highest concentration of water?
inside, in this,
In the container, right? Where I just poured the water in. Where is the lowest concentration of water?
inside the egg.
Inside the egg. So what's going to happen to the water?
It's gonna fill up in the egg.
It's going to go into the egg, right? And when all that water goes into the egg, what do you think's going to happen then?
It'll probably get a little bigger
You get the egg, the shell's going to hold it
Yeah.
so it can't get any bigger. Where's the water going to go?
inside the egg.
Inside the egg. But when it gets all filled up and there's some more water wants to get in,
It'll come out.
where does it come out at?
The semi-permeable membrane.
It goes through the semi-permeable membrane into the inside of the egg. All right? And we get all done, okay? What we're going to end up with
Oh, is it gonna push out?
is something that looks like that. Right? So, because what's happening is the water now is going through the little semi-permeable membrane down here, right? And it's going into the inside of the egg. And the more water we get in, now the egg can't blow up. It can't get bigger like those eggs over there. So the water's got to go somewhere, or the inside of the egg white, and in this case part of the yolk,
Yeah, it'll
right?
push up.
Pushes up, right? So there's some pressure, right, that pushes that up. It's just like when you drink a soda with a straw, what happens?
It'll come up
It comes up. Why?
because you're sucking air through it.
You're sucking air in.
Like you're like sucking the air up and the soda. Will
Okay,
come
when
up.
you suck the air up, right, what you're doing is you're decreasing the pressure, and then the pressure from the atmosphere is pushing down in the soda can, right, and pushing the soda up the straw. So basically the same thing is happening here. We have some air pressure pushing down here, but there's a pressure caused by that osmosis, by that water going through that semi-permeable membrane, is going to push up against the air. Now what's going to happen, how far up do you think that's going to get?
If you leave it in the water, it'll probably go all the way up.
If we leave it in the water long enough, it'll go all the way up over the top and over the top, right? But if we made the straw longer, right, to where it couldn't go over the top, it's going to come up so far. And when it comes up so far, right, the pressure of the weight of the fluid in the straw is going to push down and cause us to not for the osmosis to stop. Right? Osmosis will stop for two reasons. One, if we, in this particular case, we put enough pressure in here to push down, right, so the water can't go through the semi-permeable membrane, right, then osmosis will stop. The other thing that happens for the osmosis to stop is when the water inside the egg, right, and the water outside of the egg, the concentrations are equal, then osmosis will stop. Now that we've done all that, can we use this thing for anything? Is it any good to us,
No.
other than, making eggs shrink and expand and all that sort of stuff?
No,
No, it's no good?
I don't think so.
Why?
Because you can't even eat them.
Well, we can't eat that egg anymore, but what about osmosis? Is osmosis any good to us?
Yeah, it tells us like how the water comes out. And,
But is it any good to us?
I don't think so. No.
You don't think so?
No.
You're in bad shape, right? If it wasn't for osmosis, right, all your little cells in your body wouldn't be getting any nutrients and stuff. There wouldn't be any fluids going into them, right? And eventually, you just, you'd be like, you take a piece of celery, right? You leave a piece of celery out for a long time. What happens to it? Celery is normally nice and crisp, right?
Mm-hmm.
What happens to the celery if you just lay it out on the table, leave it lay out there for a couple of days?
It'll dry up.
Dries.
Dries up.
It dries up. It gets all limp, right?
Mm-hmm.
It's no longer crisp. If you were to take it and put it in a cup of water and leave it set for a while, what happens to it?
It'll stay the same.
It comes, even the one that's wilted sometimes, if it has wilted too far, will come back up. So if you take a plant, right, I'm sure your mother has some house plants right on, right?
Yeah.
You don't water it for a few days, what happens to the house plant?
It'll start like.
Starts going over, right? So you go, oh, my house plant's wilting a little bit. I got to pour some water on it, okay? And after a while, what's it do? It's back up, and it's nice, alive, and healthy again. And the reason it is, what happens is because of osmosis, okay? We take, just like this poor egg, right? We don't have any water. The cells in the plant, right, lose their water, and they become sort of limpy like this, right? And they're not solid enough to hold the plant up, so the plant goes, right? But if you keep giving enough water, then the cells get to looking like this, and the plant's nice and healthy, right? It's not wilted. Same thing happens in your body with all the little cells in your body. The way you get nutrients into the cells and waste matter out is because of osmosis. Right? If you didn't have any osmosis, what's going to happen to your little cells? They're going to look like this and eventually die. And if all your cells die,
You die.
you're going to. Right? So osmosis is important to us. Right? And we ought to know something about it. So now, one of the other things that we use osmosis for, right? Give me the water.
Which one?
Get this out of the way.
Water.
The water, and the salt water. Get this out of the way. This out of the way. Right? We got water, salt water, and water. Where's the highest concentration of water?
Inside the water.
Inside of water. So if I were to take now, and let's assume that that's the ocean, this is here, and I put a semi-permeable membrane in there like that, between them, which way is the water going to go?
This way.
It's going to go that way. The highest concentration of water to lower concentration of water. Now then, I know that some places in the world, right, don't have a lot of fresh water. They don't have a lot of water like this that we can drink. But they do have a lot of salt water. And one of the things that they use to get fresh water is osmosis. But if you're telling me, what you're telling me is that I take the salt water and I take the fresh water and I put them side by side and I put a semi-permeable membrane in it. And if this is the ocean and this is my fresh water, what's going to happen with my fresh water?
It's gonna.
It's going to all go away out into the ocean, right? Become salt water. But I want fresh water. I want something that I can drink. So there is a thing called reverse osmosis. Normally, osmosis, the water goes from the highest concentration of water through a semi-permeable membrane into
The lowest.
the lowest. But in reverse osmosis, we can make it go the other way. And that was one of the reasons that I showed you this thing. right? Go back and take a look at that.
Then it goes, it's like a filter, it goes up.
All right, if we put water in here, put this in the water, right? Set it down in the water.
So take out the yolk and the
All right.
water goes.
The water goes through the semi-permeable membrane, right, inside the egg and pushes this up, right? And it's going to push this up until what? The weight of the water is enough to overcome the force that's pushing it up. If I put a little extra weight on top of this, say I were to get in here and I were to blow on this thing, right, put some pressure on it, what's going to happen is it's going to reverse the osmosis. It's going to make that water go back through the semi-permeable membrane down here on the bottom, right? And so what happens is this egg yolk, the white stuff goes back down into the egg. The water comes out through the semi-permeable membrane. So if I take my salt water, my regular water, and I put my semi-permeable membrane in between them, right? Normally, osmosis, the water would go from here to here, right? But if I put some pressure over here, if I squeeze this bottle, right, put some pressure on it, I reverse it. So the water will go from the point of low concentration over into here. And well, guess what? The salt stays over here. I get fresh water over here, and I have something to drink. And a lot of places use that for fresh water. In fact, if you go to one of in Bermuda, it's a little island off the coast out here where everybody goes on vacation. Well, they don't really have any water, any fresh water. Right? They get water two ways. They got ocean all around them. Right? They get water two ways in Bermuda. One is collected off of the roofs when it rains, right? Because that's been, evaporated and left the salt behind in the sea, and you got relatively fresh water coming down on top of the roof, so they catch it and they put it in a thing called a cistern where they store it. And the other way, some of the bigger hotels, the guys with all the money, right, use this reverse osmosis to generate water. So if you were to go on there on vacation, you get a glass of water, right? It's probably come out of the ocean, right? But they use the reverse osmosis to keep the salt over here and the fresh water over here.
It's like a filter or something.
Yeah, it's like a little filter. It's one of those
Oh.
semi-permeable membrane things. Okay. Coffee time break, huh? So, let's go back and review a little bit. Brian, what's osmosis?
Osmosis, the movement of water across semi-permeable membrane from areas where the water particles are more concentrated to areas where they are less concentrated.
Okay, very good. So a semi-permeable membrane is a membrane, right, which allows some things to pass through it, and it stops other things, like the little membrane on our egg, like the membrane around your brain, the membranes around all of the cells in your body, the membranes around all the cells in plants, right, are semi-permeable membranes. Allows water to go through, allows osmosis to happen, allows water to go from the highest concentration to the lowest concentration. Of all these little bottles of stuff over here, which all have water in it, which ones got the highest concentration of water?
The water.
The water, right, the pure water. How about the salt water?
Nope.
Nope, why?
Because it has salt in it.
Because it has some salt in it. There's some salt particles taking up some space. Same thing with the orange juice. The ginger ale, it's got some sugar stuff in it, a little coloring, the dishwashing, and so forth. So the pure water is got the highest concentration of water. So, we put the egg in the water, what's going to happen?
It's gonna fill up again with water.
It's going to fill up with water because the water has a higher concentration of water than the white on the inside of the egg, and that membrane we have around it is a semi-permeable membrane, so osmosis takes place and it's going to go through. Why does it feel cool?
Because it's evaporating.
Because
The water.
you're out and have it out in the air,
Yeah.
and there's a higher concentration of water
Inside.
inside the egg than there is in the air, so the water comes out osmosis through that semi-permeable membrane, and then it evaporates and it makes it feel cool. God bless you.
Thank you.
All right, now, if we take the egg and we put it in that K-Row syrup,
It will dry up like a prune.
it'll dry up like a prune, right? It's gonna end up looking like
Touch it again.
this thing, this egg, which we've had in there for a couple of days, and osmosis took place because the water, the inside of the egg had the highest concentration of water, and the water diffused, right, out through that semi-permeable membrane into the K-Row syrup, and the egg lost water and it got all limp like that. Okay, so now then, and the reason this
It's getting higher.
getting higher and higher is because we have the semi-permeable membrane exposed down here on the bottom. Right, we have it sitting in some water, and osmosis is taking place. And when osmosis takes place, it causes some pressure, and it's pushing the inside of that egg up the straw. Right? And then we said we used osmosis, a thing called reverse osmosis, to purify some water if we needed some drinking water. And the way we do that is what?
Pressure.
We put some pressure on it, right? We push some pressure down through here, right? And what it does is it forces all this this inside of the egg back down and forces the water back out through that semi-permeable membrane, leaving the contents of the egg, the inside of the egg there. Right? My little egg here, why is that little white spot there?
Because of the air.
Because
It made it evaporate. Because it has less water in the air.
when this thing has a shell around it, it has that calcium carbonate shell, that hard shell. Right, this particular one's a hard-boiled one, right, and the shell's gone because somebody peeled it off. But what happens when the chicken lays the egg, right, the egg is warm, that calcium carbonate shell around the outside of the egg has how many holes in it? You're going to count them, right?
7,000, 8,000 holes.
17 or 18,000 holes, right? You're going to go home tonight and count them because it's your homework. And so when the inside of the egg starts to cool off, it shrinks a little bit and allows, and that gives some space for the air to come through that shell, and that's why you have that little space there.
I always wondered that.
You always wondered that. Okay, now you know. Very good. I think that'll do it for today. And remember, all you folks at home that are watching, you decided you want to try this, do what we did, right? We put some newspapers down because if you happen to drop this egg, right, you're going to have a mess, and your mother is going to be upset with you. That's it for today. So